Welcome everyone to another episode of our book club author chat. This month, our book club is reading the book Modeling Mindsets. And we're super grateful and honored to have the book author, Christoph Molnar, with us today. To kick things off, would you mind give us a introduction about yourself and the book?
Yeah, first of all, thanks for having me. And I was very happy that you picked up the book, Modeling Mindsets. Yeah, for my background, I started like as a statistician, so I studied statistics, and after that, I had did a bachelor's and a master's, and after that, worked a bit as like a data scientist and as a statistician and research. But then later, I kind of got hooked to machine learning, and actually started writing during one of my statistician's job. A book about interpretability, actually, of machine learning, because it was kind of on the border between machine learning and statistics. And this kind of got me into doing a PhD on the topic. And this also now over, so I'm finished with my PhD, and now I'm writing books full time. And Modeling Mindsets is actually my second book. Quite different from the first one. The first one was more like here different methods and how you can use them. And Modeling Mindsets is more of an abstract book, or like a higher level book, comparing the different mindsets with which people approach analyzing data or modeling data, to be more specific, because that's something I realized when I studied. I had like this perfect frequentist statistician mindset. That's what we got taught. We had a little bit of Bayesian and a little bit of like machine learning. But only later, when I then learned about machine learning, I saw like, okay, we're using the same types of models and stuff, but the approach is very different between the two mindsets. And so I wanted to write it down, all I learned about it, and think it's like a helpful guide so that you can see how the different mindsets are between different fields.
So I guess we have all read the book, and I love it. I think it's a really nice, easy read. It's very relaxing. It's like not super technical, but also a really good refreshment of all the concepts. But for people who have not read your book but are very interested, would you talk a little bit about what are the mindsets you describe in the book? And why do people need them? Or like,
yeah,
what are the good practices you think people can get from reading this book?
Yeah. So you could summarize it in super simplistic way if you say it's like machine learning versus statistics, because that's something you see online as well. Like, okay, what's statistics? What's machine learning? Some people say it's the same. Some say it's different. And the book goes a bit more like fine-grained and goes into the different flavors also of statistics, adding also causal inference, and talking about the different mindsets in machine learning, like supervised machine learning, unsupervised, because I also think that these approaches are quite different and require you to think differently about your data and how you model the world. And I think it's useful so these are archetypes, so nobody's like 100% one of the things, or if you approach a problem, you might do a mix actually of these mindsets. But I think it's worth having these like as archetypes, like as extreme forms, just so you can recognize them. Because I've seen things like there's papers written about, is logistic regression or machine learning better? And I think that's not a good question, because it's you either do machine learning and then you just compare a lot of models, and logistic regression might just be one of them, and you could still write a paper about, hey, logistic regression was enough for this task. But I didn't find like this dichotomy useful in terms of like we have to share the models. It's not the models that are belonging to one or the other direction. It's just different mindsets with which we approach the problem. And I think it's worth having this in a book, so you could give it to people and people can read it and see them as different mindsets and not different. And they have quite a big overlap in methods, actually. And you can understand other people much easier if you understand which mindset they are coming from. So I also had like discussions when I was new to machine learning. I had discussions with statisticians about model performance, because they were not much focused on the performance, but more like, okay, R squared, which is a type of performance, but not measured in a test set. And so this is a very different mindset. And it was difficult to talk about this, even though I was a statistician also at this point.
So which mindset do you think describe your work, or like what your experience the most?
So I think the one that I think in about the most is supervised machine learning, and plus frequentist statistics, I would say. Well, these are the ones that are most come easy to me, because I learned most about them, and I think they're both very practical mindsets. Yeah.
Right.
So.
Yeah, I feel you. I feel like right now I am pretty much the same as you are. Like, but when I was in my social science PhD, I feel like it was very much in the statistical modeling mindset, like doing, like I said, R square. We don't really care about model performance, like cross validation, nothing like that. But like goodness of fit, R square, those kind of measures, it's like completely different. Those are not the focus. Yeah, so I want to open the floor to our audience. If you guys have any questions, feel free to ask right away, or type in the chat if you don't feel comfortable to speak up. Anybody have questions?
Yes, I have a question.
Yep.
I'm Amar. So my question is that in which industries, in terms of deployment of machine learning solutions, do metrics tend to matter more? Like in any social science solution based on machine learning, at least to where I have read about, they really don't look at accuracy because it's important, like legit impossible to get a 50% above accuracy in a solution like a human resource predictor model. Just giving a simple example. But in like situations like, let's say, facial classification, it's possible to get an 80% plus accuracy because the same person can visit the same place twice. Just giving a small example for understanding. What would you have to say to that?
So your question was about like in which industry is more focused on metrics? Was that the question?
Yeah.
Trying to rephrase it. Oh, that's a good question. So my experience so far was more in like one was in a fintech startup, the other was more like in medicine. I think it really depends more, maybe more on the product itself than the industry. So when you're building like a first prototype, you might be less focused on, okay, how good is the accuracy and stuff like this. I mean, should have at least a certain amount of accuracy or whatever metric you're using. But if you have a model, and then you have a lot of other questions like, okay, how does it even fit into the business? Is it the right way to use the model? Should we use a model? But if you have an established model, let's say for targeting ads or something, where every like percentage in accuracy you can translate into hundreds of thousands of dollars or whatever, then it's more important, I guess, or there will be more focus on just improving the metric a little bit.
I see. Thank you.
I guess I can keep asking questions if other people doesn't have more questions right now. But I'm a big fan of your first book, Interpretable Machine Learning. I have read that book, big fan. I was wondering, like, which mindset was that book focused on? Because it's like you're using statistical models to explain, or some machine learning models to explain machine learning models. And those models are even more complicated than the original machine learning models. When I talk to people about different methods, the interpretable methods, and people is like, you're trying to make it simple, but why is your method like more complicated?
So interpretable machine learning is, so I'm already thinking about like the second edition for modeling mindsets, and one candidate of a mindset is interpretable machine learning, but I'm certainly biased there to say it's a mindset. So I would say that the models originate from supervised machine learning mostly, if you do interpretable machine learning. But there are also approaches for clustering, so coming from unsupervised learning and then interpret the results. So that's not a perfect match with supervised machine learning, but I would say most approaches come from there. And it's kind of a mix between machine learning and statistics, but you kind of want to have the things that you have in statistics, like interpreting the coefficient of a model, but you don't get a coefficient because you're using a random forest or a deep neural network. So you try to replicate something similar with interpretability methods. So it's kind of a fusion between mindsets, but not a perfect fusion, but you're trying to have to achieve what you have in other mindsets in the same mindset in machine learning.
Right. And the methods are so different. There are so different
Yeah.
different kinds of methods. And you have a new book on SHAP.
Yeah, it's a deep dive on one of the methods. Yeah.
Yeah, that's so cool. Looking forward to reading that one. That goes into another question from the Discord channel. Actually, someone was asking, are there other mindset that you might add in the future? I guess you mentioned.
Yeah, it's a good question. Yeah, so yeah, I'm thinking about this a lot because there's like lots of things that you could frame as mindsets, I would say. So the scope for the book was that each mindset should have like a model, or should model the data. So I kind of kicked out things like just descriptive statistics or things like this. So what I was thinking to add was, because of the hype, of course, a bit, but I think it's a new mindset, is large language models. It's kind of like the prompt engineering and how you think about the world when you use large language models. At the same time, it's a kind of a meta mindset, because you already train the model and afterwards you use model again with that model. So by prompt engineering, for example, like one-shot or few-shot learning and stuff like this.
That makes sense. But
yeah.
That's similar to the deep learning mindset your book has mentioned, which also mentioned like fine-tuning, prompt engineering, but like
there's some overlap. Yeah, that's true.
More on the not on the mechanism of deep learning, but like use the pre-trained models.
Yeah, using the finished model, I would say. Yeah.
Right.
Then one is, which is still just missing, I would say, self-supervised learning. Many people categorize it as unsupervised, but I think would be worth to explore it as its own mindset, because all the generative AI, or most of the generative AI models that are now like popular, they're all based on self-supervised learning. One other, then some quite different direction in which I wanted to edit mindsets was more on focus on data. So one is like the classic survey statistician who is questioned with, okay, hey, we want to know how many people are doing X, or how many, like, if you want to have a survey like all of the country, or what would you vote on Sunday? So your job is not to have a prediction model or anything, but to have a good sample from your population and a good estimate of, for example, like which party you would vote, or something similar. And that requires a quite different mindset to all the other mindsets.
I really like the survey one, because survey science is often overlooked. People think it's so easy, but to get a representative sample and to mitigate all the survey biases, which is, there are a lot of biases out there, it's a whole field of research.
Yeah. And there's also, in survey sampling, you also have it's also different from the other statistical. I mean, it's part of statistics, but it's different from like frequentist inference, for example, in the sense that So you have a different idea about variance, for example. So
Mm.
because you know, in theory, all of your population, so if you would sample everyone, you would have 0 variance left. So your variance is just because you haven't sampled everyone. So these are like a bit philosophical maybe, but these are, yeah, quite different way to think about your problem and how you model your world. And
Yes. Okay, keep going.
yeah, the other mindset that I also thought about adding is also data focused, or maybe more experiment focused. So like design of experiments direction. It would a bit fit with the causal inference mindset, but the causal inference mindset was more about already having the data, then thinking about causality between the variables and modeling this in a causal way. And design of experiments would start with, hey, we don't trust observational data at all. We want to design an experiment. So this would include clinical studies, for example, or anything, or A/B testing in marketing. These are also a very different idea how you model the world, because you say, okay, I have to do an experiment. Afterwards, you usually also use frequentist statistics like hypothesis test or other things. So there's also, again, a connection between mindsets. So you have to connect it with another mindset to make it work, or to get a model in the end. But I think it would be worth exploring as an additional mindset.
Yeah, I totally agree. So it's the causal inference from the early stage experimental design versus causal inference
experimental design,
from the data, the modeling part.
Yeah, where you like think about doing the experiments and designing the experiments and how you design them and things like this.
Wow.
And
So
last
your book
but not
will
least,
cover everything.
yeah,
Your book will cover everything.
that's the other thing. I don't want to make it too big, because I think one of the nice things is that the book is so short. And
Oh,
with
I
each
love how
mindset,
short it is.
yeah, and with each mindset it would get longer. So I have to strike a balance between adding more interesting mindsets and keeping it
Right.
short-ish.
Yeah. And did you have another mindset to add?
Yeah, one would be visualization. So visualizing your data. You could argue that by creating plots and visualizing your data, you have a model in your mind, and you map your data to dimensions and other attributes of your graph. So, and you could argue that it's a model, but I'm still not sure if I would add it as a mindset. But yeah, I'm considering it.
Wow. Visualization is another hard topic.
Yeah. Yeah, but it would make for an interesting perspective, I think. Is this like a modeling mindset? Are you building really a model of the world? You could argue it maybe. I mean, there's things like the grammar of graphics where you say, okay, you have elements representing your data. And yeah, many things that you can see or do with other mindset, you can also do by visualizing your data.
Yeah, exactly. So we have 2 more questions in the chat. Let me start with the mindset question first. What mindset would be used to model the modeling mindsets? And does such a model exist?
Okay, maybe this is too abstract for me. What mindset would be used to model the modeling mindsets? Would be like a middle level. So it's well, we're leaving like the data and going to the mindset level. So maybe the question is too meta for me.
Okay, let's go to the next one then. What advice do you have for individuals looking to pursue a career in data science with focus on interpretability?
Oh, that's a big question. What advice do you have for individuals? Well, I would just pick, depends on where you stand yet. But I think both statistics or machine learning could also be like in a more applied sense, that you study something else or just get started with a job or a project. But I think it doesn't matter too much with which mindset you start. You just have to start, because if you know one mindset, it's both harder and easier to learn other mindsets. If you're open-minded, it's easy to learn the others because some math will be the same, some tools will be the same. If you know Python, then it will be useful no matter which mindset you work in. And if you want to focus on interpretability, well, then like classic statistics, like frequentist statistics and Bayesian statistics, they are more focused, I would say, on interpretability, and it might be a better mindset than maybe to start with. If this is your focus, then maybe start with statistics, because it kind of makes you think about like the data generating process and things like this, which I think helps even if you later do machine learning.
Awesome. Thank you. Any other questions people have?
Hey, hi. My name is Nisant. I've been a big fan, has been following your books and on your LinkedIn post about all the insights. I've been working for a couple of companies, and my expertise has been around explainability as well. And your book has been great instrument in that journey for me. So question I have is recently, every time there is a data science problem comes in, LLMs are thrown into the picture a lot. For example, says that, hey, we have, let's say, customer data, and we want to segment into, let's say, positive, negative reviews, customers review, for example, just taking a random example. And so there are two approaches to take this problem. And a lot of people say that, hey, why don't you use just LLMs and ask LLMs, just ask LLMs, like, here is the data, tell me is it good or bad, compared to, maybe I can do some more classical, more traditional, let's say, regression models or things like that, use something much more classical way of approaching things. So how would you approach that kind of problem? Like when you're thrown a problem and then you have some buzzword kind of, like, what are the things that you try to optimize when you think about a problem?
That sounds more like a manager problem than a modeling problem. I think that's like very common that people like pick up, oh, a new hype. Why are we not using this? And to some degree, it's worth exploring. And sometimes it's just a distraction. So I guess it's more like than about people. Like, how do you tell your manager or whoever comes up with the idea and kind of forces you to work with this? Do you tell them like if it's good or not? I mean, one thing you could do is like, if you're sure it's not a good idea, then explain it to them, or maybe you can even showcase it and compare it to a traditional approach, that the traditional approach works much better. This could, depending on the problem, this could be a lot of work, of course.
Yeah. Okay. Yeah, I think that makes sense. And just as a part of discussion, oftentimes something that I don't know if other people agrees with that or not, but two things which I talk about is, of course, as a interpretability in back of my mind. LLMs are still not as interpretable as we would like it to be. Even the simple, like, for example, if I have even a simple neural network model, let's say one of the just forgot. OpenAI has those models to. Running Saply, Whispers. Sorry, Whispers. Running Saply on the Whispers, it just takes so much time for the single predictions. Like at some point, you feel like, yes, you have all these big and expensive models, but they just take so much time to generate the predictions, and at some point, they're just not fitting into your your SLA. Like your model has to generate a response in certain amount of time, and it's just not able to do that. So that often comes into picture. Like, hey, why? We need to also think about how complex the models are and how simple they are and how much explainable they are. And it's really hard sometimes because people often try to optimize for the accuracy and not think about all the other dimensions as well. Explainability and time, which I see always a big hurdle for me to communicate. But your thoughts about that, if you have any, when we think about modeling.
What was the last bit? Did you say?
Do you have any thoughts about that as well?
Yeah. So especially, so I thought about it, like interpretability of large language models. And one thing you mentioned is the problem that it takes just a long time to compute, especially SHAP. The other problem is that both your inputs and outputs are very high dimensional. So even if you could have a fast way to compute SHAP values for these, then you end up with, depending on how you tokenize it, but for each output token, you have one SHAP value for each of the inputs. So this is and then the same again for the other output tokens. So this is a huge, and just like one input, one output, and you have a lot of explaining already to do. And I don't know how helpful it is to highlight single words and from the input, then how important they were for the output. So for large language models, I haven't seen something really satisfying yet as in terms of interpretability. And I'm also not sure what you would like to see, like if you could wish for anything, like or be imaginative, like what would be a good explanation. I don't know. For large language models, it's much easier if you think about tabular data, because then you have just your columns and you can assign importances to single columns. And with large sequences, both whether it's image or text, it's just very high dimensional and much harder.
Yeah, I don't want to capture the whole conversation, so I will stop and let other people talk. Thank you.
Thanks for your questions.
Really useful. Yeah.
That was a really good question. I was like looking into that as well. I feel like Shapley value doesn't really make sense for large language models, even if you get the result, it doesn't really make sense. It's not what we want. So I don't know. Maybe like having the large language model to explain itself in the future will be helpful somehow. Somehow, if that could happen.
Yeah, that's what OpenAI like used. I forgot about the approach, but used like GPT-4 to explain GPT-2. And but yeah, this was on a neuron level. So they assigned meaning to individual neurons. That's a different approach from like all these postdoc approaches. So because it's not studying the behavior of the model, but instead trying for the individual components of the model, which of course for deep learning are like layers or single neurons. I think they assigned the meaning to the individual neurons, but they automated this with GPT-4 to try to figure out what the meaning was of each, or what like semantic meaning each neuron grasped, like I don't know, things like color or similar. Yeah, I think it's difficult. I mean, they did some checks that this could be reproduced and things like this, but yeah, also, what do you do with this in the end?
Right. There is a question in the chat. Wow, it's a long wall text. Oh, but great questions though. I guess the first question, is it possible there exists a universal modeling mindset that encapsulates all other mindsets? The second question is it worthwhile investing time in becoming proficient in several or all of the modeling mindsets?
Okay, I'll start with the second. So worthwhile investing time to become proficient. Yeah, so that's kind of the last chapter I write about. It's each of the mindsets you can go very, very deep in each of the mindsets. So if you want to be an expert in deep learning, you can spend your whole career on this, obviously. Or if you study frequentist statistics, there's so many models to explore, so many types of tests and a lot of theory. So you can easily become or easily spend your time only on one mindset. So the question is, how obviously it would be great to know all of the mindsets. So I recommend in the book that you go deep on like 1 or 2 or 3 of them, and just because it's practical, just to know the other. So learn a bit about most of the other mindsets. So you can at least like recognize the basic assumptions in these mindsets and how people approach problems when they. So let's say you focus on unsupervised learning and and deep learning, self-supervised learning, like this direction. So at least that you know when people use frequentist statistics or Bayesian or supervised learning, that you understand like what the ideas behind those modeling approaches, and when they talk about certain methods, that you just understand what they are talking about. So this is like the idea of the T-shaped modeler, that you go deep in a few of the mindsets and get a rough idea of the others. It's also the idea of the book, so that it makes it easier to get the very high level idea of the modeling mindsets. I mean, obviously it's just like 5 pages, so you can't go too deep there. But I think it could be a good entry point if you have no idea about what's going on with, let's say, causal inference or so. Yeah, that was 2 questions. The other question was, okay, so there's in many STEM fields a kind of truth, and so is there some mindset that includes all the other mindsets? Yeah, there are some approaches. So you can show some similarities between mindsets. Not in terms of, okay, there's like one theory to rule them all, or to capture them all. So you can show, for example, that frequentist models are a special case of Bayesian models with a special prior, and you can also show that optimizing certain loss functions, which you would do in supervised learning, is the same as doing like maximum likelihood estimation in frequentist statistics. So you can show some parallels or that some things are equal between the mindsets. But I think on a very basic level, they are philosophical differences on what assumptions you make about the world and how you best model the world. So yeah, I haven't heard about any theory that could like capture all of them in some way. I mean, maybe induction would be the philosophical concept that kind of unites all of them. So induction as in learning from like special cases or individual cases about like general rules. So that's common between all of the mindsets. And they just make different assumptions about like what we're allowed to do with those general rules. So are we allowed to make predictions with them? Are we allowed to interpret them like in terms of posterior distributions or make statistical hypothesis tests and so on? Yeah, I guess this would be the overarching like uniting theory would be induction. I don't know.
Wow. Okay. I do have a question about the book specifically. There's one chapter I was like a little confused on, like
Okay.
because when we talk about statistical modeling, it's the Bayesian frequentist, but then you included likelihoodism. I thought, like before this book, I thought it was part of the frequentist side of things. So could you talk a little bit about the difference?
Yeah, this I also didn't know about this before, so I don't know, maybe I made a bit too big thing out of it by adding it as a mindset, but I was just like too much captured by this idea because it helped me understand better the difference also between frequentist and Bayesian statistics. And so there are like books also about likelihoodist statistics. And so at first I was like, also when I was reading about it, I'm like, it's just frequentist statistics, because likelihoodist approach is also rejecting priors, so you don't get all these like base theorems and posteriors and all the Bayesian statistics. But they also reject like the frequentist approach. so that you interpret everything as in terms of repeated experiments, because that's what you basically need when you want to make create confidence intervals or do hypothesis tests. And I think that's very interesting to think about, because then like you have to think about what's left if you don't do either priors and posteriors and thinking about repeated experiments. And the only thing you're left with kind of is the likelihood itself. So you have the likelihood function, and you can compare the likelihood between two models then. And I think also that's the reason then in the end why this is not its own like often practiced mindset, because it's difficult to make decisions with this mindset if you don't, because this frequentist gives you a way to make decisions. So I mean, that's in my opinion the strongest mindset for making decisions. That's also why it's popular in science, because you have the testing and you can say it's significant or it's not significant. And in Bayesian statistics, you can express it as a degree of belief and say, okay, this is my posterior function, so that's what I think what a parameter is. But with likelihood, this approach, you just compare the likelihoods, and you don't have that decision-making ability. Yeah, the chapter when I wrote it, it was very long and very technical, and I realized, oh, okay, I wrote it in this way because I was just learning about it. So I just wrote it for me, like my whole like thought process when I learned about it was also very interesting on like the writing level to see how different it was from the other when I wrote the other chapters, where I was much more comfortable writing about them.
Yeah, I mean, it is used in both Bayesian and frequentist. I understand. I see the difference. It's just like it's a new concept for me as a new thing.
Yeah, I think. Yeah, I thought about removing it as a mindset actually, but I left it in the book because I think, at least for me, it helped a lot to differentiate more the frequentist and Bayesian approach. So
Right.
I understood much more about because frequentists always feel natural for me, and I never realized that you always have these assumptions of, or this interpretation of, like if you repeated the experiment 100 times, 95 out of the times the confidence interval covers the true parameter, blah blah blah, that this is kind of an add-on to the likelihoodist mindset.
Right, that makes sense. I think it's definitely valuable to read this chapter. Maybe your longer version of the likelihood could be another book.
Yeah, yeah. Guess I'm done with exploring this corner of data science.
Okay. We got more questions. Is logic and human reasoning completely probability? Oh, that's a good question.
I think that goes more into psychology direction, the question. I interpret the question as is logic and human reasoning, like if we're thinking in probabilities. I think there's research showing that we're at least not that good at estimating probabilities. So I think in both directions, like over and under estimating probabilities. Yeah, but it's not my field of expertise to like talk about psychology. Yeah, logic itself, like not as in terms of like how humans think, but the field logic. I thought about adding it, or like rule-based systems, but I excluded all these approaches because I wanted only approaches that kind of are learned from data. And for rule-based, it's more like, okay, handwritten rules and stuff like this.
Next question. What Python tools do you think are worthwhile investing time into for people wanting to get started in data science?
That's okay. Yeah, it depends again which mindset you're starting in. If it's machine learning in general, I mean, scikit-learn is the big. I think scikit-learn is a great start for supervised machine learning, especially because it's just that the API is so clean, and it helps you understand the different steps very well, I think, in when you do supervised machine learning, and also a lot of other packages adopted the same style of API, at least in the supervised learning space. So if you want to do machine learning, I would start with scikit-learn. Yeah, for other directions, so for statistics, I use R more often. So if you want to go in that direction, especially for plotting, things like ggplot are really useful. Yeah, I never got to like matplotlib. never got got proficient in it, I guess. Always asking ChatGPT to help me with matplotlib.
It's interesting. A lot of like the new statistical models or like stats professors, they really like R. So it's frustrating sometimes because I use Python, and then if I need to investigating something new, like a research paper about a specific topic, I have to use R because that's only available in R. It's just interesting.
R was also very big when I was at university studying statistics. It was only R, so I only learned Python afterwards. Yeah, I don't know. It's written by statisticians for statisticians. It's quite a colorful ecosystem. I think Python for me feels much cleaner, but R has like a lot of special, like as you say, all the statistics approaches you will find in R.
Yeah, it's very interesting. There are a lot of fun things in R. I used to use R a lot in grad school as well.
Cool.
Yeah, the next question. I really want to ask this question too. What are you planning next? Working on a new book?
Yeah, so I recently published the book on interpreting machine learning models with SHAP, which is a deep dive on using Shapley values to explain machine learning models. So this was a very practical book, very technical, focused on this method. And now, so I'm always working on two books kind of at the same time. So I'm doing this full time also. So I always need to have another project when I get stuck with the other. And one book I'm writing at the moment is together with a co-author for the first time with Timo. He is like a former colleague and a friend of mine. And this book is about supervised machine learning for science. And the idea is that a lot of people are already using supervised machine learning to model their scientific questions. And often this replaces like statistical models that they would have used before. And this book is kind of a mix between philosophy of science and practical considerations. So we are writing a justification why it's okay to use machine learning in science, like what are good reasons to do it, and also bringing a lot of puzzle pieces together that you need in science, like causality, interpretability, robustness of your models, how to infuse domain knowledge into your models, how to make sure your data is representative. And yeah, this is one project I'm working on at the moment.
So when you talking about science, exactly what you're talking about, because science is a huge word. Could you give us an example?
Sorry, I was just reading a question. Could you ask again?
Oh, sorry. I was
distracted.
I was curious about the word science you mean in this book. Like, could you give us an example, because science is such a big word.
Yeah, maybe. Yeah, this also working title, so we're still figuring out how to call it. So I would say like in research, and examples that we use is for example, in ecology, a lot of people are using already machine learning to study, for example, species distribution models. So they study where certain species occur, like an elephant, for example, and they turn this into a prediction task and model it as a predicting from climate and many factors whether the elephant will occur in a region or not. So this a use of machine learning and for a scientific question. Another would be
you need some domain knowledge in a specific field then.
Yeah, so then you have, I think it raises a lot of interesting questions if you use machine learning, because you, instead of like having your own theory why and how the elephant like occurs in certain regions, you collect data and let the machine learn about the relationship between like climate and regional attributes and the occurrence of the animal. And I think, yeah, it raises a lot of questions and a lot of needs also, like about interpretability, questions of causality, how you also infuse domain knowledge that you already have in your field into the model. So I think the book is actually not only for scientists. I think many data scientists would benefit from it, but it helps with the scope to think about science.
When is it gonna get released?
So for this book, I'm doing an open release again, or we are doing an open release. So it will be similar to Interpretable machine learning, that there will be a web version, which is free for everyone.
Oh, nice.
And yeah, so we are done with like the first half of the book, but just a draft. So we will send it out soon to test readers. And yeah, then based on their feedback, I don't know how long it will take. But we're planning to release like the in progress version. Then if this first, let's say, half of the book is done, or then we will publish it and continue writing it chapter by chapter.
Nice.
So I'm hoping, yeah, I don't have a deadline or anything, but hoping this year that we finish with put something out already.
Really looking forward to reading it. Sounds interesting. Yeah, I've got another question. Oh wow, 2 more questions. Let's go with the second one. Do you think your work has already made an impact? I think so. What do you think?
Yeah, I think it's a good question. And the question is like, how do you measure the impact? It's very difficult because I don't get like well, on the website I can see how many people are reading the book, but even then I don't know what they're doing with it. But I've heard from a lot of people, for example, that they're using interpretability and the book Interpretable Machine Learning for teaching, for example. So I already know, okay, university classes are now based on a book. And other people have said that so most feedback was about the interpretability book. I guess, yeah, it's the most famous of my work so far yet. And yeah, so that I got the feedback that many people are using this in their work and has helped them better understand the topic. So yeah, I think it has made some impact, but it's really hard to assess like how much and what exactly. So it's just like random feedback from here and there.
Yeah, I definitely find your book valuable because I have used some of the techniques, and some interpretability techniques are hard to understand, and your book really helped me understand the concepts. Well, thank you. And one more question from the chat is about deep learning versus rule-based reasoning.
Yeah. Yeah. Okay. Yeah, my statement previously wasn't about like if it's worth or not worth. It was just I just had to like put a scope for the book and like what's called here good old-fashioned AI, like the rule-based system, I guess. I just put them outside of the scope of the book, but not because I don't think they're bad or anything, but I wanted to focus more like on learning from data, like automatically learning from data. So, but I thought actually a lot about including this. Yeah, just didn't make the scope of the book. Was no judgment on whether it's worth or not.
Thank you for clarifying. I guess one last question, since we're about time. Applying ML to scientific discovery, you have mentioned, is absolutely interesting. Is that also related to physics-based machine learning?
Good question. So I'm not sure what refers to as like physics-based machine learning. Do you mean like the application of machine learning in physics or more specific approaches? So actually my co-author is very interested in physics, so we might include examples from physics. scientific discovery. Yeah. One other comment about the question. So it's not. Yeah. Okay. Yeah. Well, you could call it scientific discovery, I guess. Yeah. In theory, the book should cover every part where supervised machine learning is used. So it should also cover like physics-based approach, machine learning questions. So we're not writing the book just for ecology or whatever, but just from a general point of view, like you're doing research, you want to find stuff out, you're using machine learning, which is meant to produce predictive models and not necessarily produce scientific knowledge. How can you still like justify this, and what are the tools that you can make your models work for your needs as a scientist? So that's the basic idea of the book.
Okay, thank you. So it's not specific about one field. Yeah, that's awesome. Thank you so much for this discussion today. Really appreciate the book and appreciate you coming here, spending time discussing the book with us, and looking forward to your new books.
Yeah, thanks so much. So had a lot of fun discussing your questions. I think there were a lot of good questions from you guys.
Yeah, thank you everyone for attending and for watching this video. Thank you. Bye-bye.
Bye.